Okay, today's video. For those face-to-face class kids, remember, you've got the hard copy in front of you. What I'm doing here on screen, copy, word for word, number for number, what I'm doing, working the problems and everything. Bring this with you tomorrow in class. Have any questions that you need, ask those, have them ready. And we're going to do the problems that I don't do on this video, we'll do in class tomorrow, to have any questions or anything. And then we'll do individual work, okay? Make sure you bring this with you tomorrow in class, all right? And then you're going to put it in your notebook, which will be a quiz grade at the end of the unit. Okay. All right, so systems of equations, we're still on those, and we're looking at 3 different ways to solve. Okay, we've looked at graphing. You just graph the 2 equations and find the intersection. If they're parallel, if they have the same slope, that means they're parallel, so there's no solution. And if it's the same line, if the equations are both the same line, one of them's in slope-intercept form and one of them was in standard, but when you put them both slope-intercept, you see it's the same line, then that's infinite solutions, okay? All right, the other way we're going to look at today, let's suppose that you've got a real-world problem and you've written an equation for the situation, and you end up with 2 equations and you need to solve for x and y. This is where you're going to use systems. There's 2 different methods, and the method we're going to look at today is substitution, okay? Some people like substitution, and some people will like the one we'll do tomorrow, called elimination. But you need to know how to do both. Make sure you know how to do one really well, okay? And this is, you say, well, graphing's easy, I know how to do that. But wonder if x is, the x coordinates 399 and the y coordinates 12. Okay? You don't know how to plot. You can't look at a graph and get 3.99. Okay? So when you're dealing with money, which most of real world application is, you need to know how to do one of the two methods, okay? All right, so substitution method is, I do that every time, don't I? It's a method of solving systems of equations by substituting equations within one another. All right, a method of solving systems of equations by substituting equations within one another. All right, I know that kind of sounds like what? Well, you'll see it in a minute. All right, step 1, solve one equation for x or y. So we want it to be x equals, or you can have y equals. Okay. Step 2, substitute this expression into the other equation and solve for the variable. Okay? So you're going to get one equation, at least one equation is going to be either x equals or y equals, and then whatever it equals, you're going to plug that in for that variable in the other equation. All right, and then step 3 is to substitute your answer into the revised equation from step 1 and solve for the other variable. Okay? All right, let's look at this. So step 1, the one you really need to remember, is that you need to get at least one of your equations where a variable's by itself. Either x or the y, it doesn't matter. Okay, in number 1 here, we got both of them have a variable by itself. So that's good. So what we're going to do, it says that y is this. Okay? So y is an unknown value, right? Well, 4x minus 1 is that unknown value. Okay? And then down here it says that y can also be this. So you remember those transitive property, if this is and that, then this. Like if A equals B, then B and B equals C, then A equals C. All right, so think of the same thing. Here we got y equals this, and over here we got y equals that. Well, if the y is equal to both of them, then they are equal. All right, this is when you have the same variable. So I can write it as 4x minus 1, and I can substitute the y with the other part, 2x minus 5. All right, and then you're just going to solve for x. Because see, now I don't have any y's in there, so I can solve an equation. When I had 2 variables, I couldn't. All right, so we're going to get a variable on one side only. So 2x minus 1 equals negative 5. You're going to add that 1. 2x equals negative 4. So x equals negative 2. All right, so I found out what the x is. So now I need to find out what y is. So I can take either one of these equations. So I'm going to take the first one up here, y equals 4x minus 1. And I'm going to substitute that x with negative 2. So y equals negative 8 minus 1. So y equals negative 9. All right, so there's our solution. And it's an ordered pair, right? So x comes first. So my solution is the ordered pair, negative 2, negative 9. All right. So it's pretty easy when they're both y equals or they're both x equals. All you do is set one equals the other and solve. Now, let's look at number 2. Here we've got, remember step 1 is you need to get solve one equation for x or y. Well, we've got one equation here that's solved for y. The other one's not, though. All right, so since we have this that says that y is this amount, then I'm going to substitute this 6x. I'm going to substitute it for y because they said y is that. Y equals 6x. So I'm going to, instead of y, I'm going to put 6x there. Okay? So I took this 6x and put it there, replaced for y. All right, and so now I'm just going to solve. So 2x plus 3 times 6x is 18x equals negative 20. So 20x equals negative 20. So x equals negative 1. All right, so now we can take the negative 1 and go back to my original equation, y equals 6x. And this time we're going to substitute the x with the solution I just got. So we come up with y equals -6. Okay, so my solution is the ordered pair -1, -6. Okay, let's look at number 3. All right, I'll tell you what, let's go on down to look at number 4. Okay, well, that one's just like that. You're still substituting that. Well, let me do it since it's not just one term, you got 2. All right, so in this case, it says that x is this, right? It said x equals this amount. So I'm going to substitute this for that x. So I'm going to have 2 times x, so 2 times 4y plus 7. Then finish the equation out. All right, so all I did was take that and replace it with the x in the second equation. All right, so we need to distribute. So 2 times 4y is 8y. 2 times 7 is 14. Minus 6y equals 12. Combine your like terms. They're on the same side, so you don't do opposite. 8 minus 6 is 2y plus 14 equals 12. Minus 14 minus 14. So 2y equals -2. Y equals -1. Okay? So I've got y equals -1. I know what y is. So what do you think I can do now? I have to find x. So if I know that y is -1, then I can go back to the original equation. X equals 4y plus 7. I can replace the y with -1 from over here, plus 7. So x equals -4 plus 7. So x equals 3. So my solution is going to be 3, -1. Okay, that's your solution. If I was to graph it, they would be intersecting at that point. Okay. All right. Let's see. Go ahead and turn over. Okay, let's look at number 6. Okay, so on this one, number 6, neither one of the equations has a variable isolated. All right, so we need to get x or y by itself in one of those equations. Okay, so if you're looking at the two equations, which one do you think it would be easier to get the variable by itself? Well, I would say, since this y is already just one y, I'm going to do it. It saves me a step. All right, so I need to put it in slope-intercept form, y equals. So I'm going to bring the 2x over and do the opposite since it's going to the other side. So now I'm going to replace this equation with y equals -2x. What was my number underneath there? I can't see. 9 plus 9. Okay, so now we're going to be dealing with this equation, and we're dealing with this equation. Okay, so let's look at this one. It says y is -2x plus 9. So y is -2x plus 9. So I'm going to go to this equation, 2x minus 3 times y. And it said y is negative 2x plus 9 equals negative 11. So now I've only got one variable, x. I'm going to solve for x. So 2x, we need to distribute. Negative 3 times negative 2x is 6x. And negative 3 times 9 is negative 27 equals negative 11. Combine your like terms. So 8x minus 27 equals negative 11. And then we're going to add 27. So 8x equals negative 11 plus 27 is 16. And divide by 8, so x equals 2. All right, so I know what x is, so I'm going to go in here and replace x with the 2 from over here. And that's plus 9. So y equals negative 4 plus 9, so y equals 5. So my solution is 2, 5. Okay. All right, let's do another one like that. Let's look at number 9. All right, again, we need to get at least one of these equations. We need to get the variable by itself. And I would choose this y because it's a 1y. All right, you always want to pick one. If it's got a 1y, your 1 is a coefficient, pick it. Okay, so we're going to isolate this variable. So I'm going to have y equals 18 minus 2x. All I'm doing is bringing this over and subtracting it, right? So now I have these two equations. Okay. All right, so this tells me y is 18 minus 2x. So I'm going to substitute in my first equation. I'm going to substitute y with 18 minus 2x. Okay. Now I need to solve for x, so I'm going to distribute. So 6x, 3 times 18 is, that's going to be 46. Oh, no. No, it's 54. And then minus 6x. No, 3 times, yeah, minus 6x equals 54. And you say, well, wait a minute here. 6x minus 6x, when I combine like terms, my x's cancel out, and I'm left with 54 equals 54. Okay. Do you remember when we were solving equations and everything, we said what happens when the variable cancels out? If it's true, then it's going to be infinite solutions. Okay? If it's false, it's no solution. And if we had put both of these in slope-intercept form, we would have seen that it's the same line. Okay? So even if you don't put both of them in slope-intercept form, or y equals, you're still going to find out. It'll still let you know if it's parallel lines or the same line. Okay? So kind of wanted you to see that there. And let's do one more. Let's look at number 11. All right. I'm going to isolate that variable. All right, so I'm going to bring the 3x over, but I'm left with, and this is a common mistake, that negative goes with the y. So I'm left with negative y equals negative 8 minus 3x. So you need to divide all this by negative 1, all right, to make that a positive y. So you're going to end up with y equals 3x plus 8. It's going to change all your signs to positive. Okay, so now we've got this equation and we've got this equation. Okay, so these are the ones that we're dealing with. All right, so I'm going to replace the y with 3x plus 8. So we've got 5x plus 2 times 3x plus 8 equals 5. So 5x plus 6x plus 16 equals 5. Combine my like terms, so 11x plus 16 equals 5. We're going to subtract 16, so 11x equals negative 11. So x is going to equal negative 1. Alright, so now I know what x is. I can just go and plug it into this equation. So y equals 3 times negative 1 plus 8. Y equals negative 3 plus 8. So y equals 5. So my solution is going to be my x is negative 1, my y is 5. So the coordinate negative 1, 5. Okay. All right. My face-to-face people, make sure you bring that to class with you tomorrow. And we'll finish up and do some practice work on it. Okay. My virtual, make sure you keep your notes with you to have something to look at. And since I can't see your notebook, if you will, after you take your notes, if you will upload it to me, well, you can't do that. Let me think about that and I'll get back with you. Just make sure you keep your notes there, okay? All right. All right, y'all have a good evening.